Thank you for joining our webinar session, and a warm welcome to everyone. We can see there are few attendees still joining in. So while we have few more guys coming in, we'll just proceed further. So welcome to the GIS Conversations webinar series. This is the second event or the first webinar for this FY, and we'll proceed with this. So GIS Conversations basically is a program that combines the innovation, user engagement, brand strengthening, and new partnerships. So what exactly is GIS Conversation? We have different events related to GIS Conversations. We have event that is meetups and webinars. So last month, there was a meetup related to Esri innovations and location insights. This month, we have a webinar. So followed up with the next month will be again a meetup. So this is an overview of our program or agenda for the GIS Conversations. So for the details of the programs, you can always see it on the Esri Singapore website, wherein we will post all the program agendas, as well as you can express your interest there. So without any further ado, let me pass it over to Lincoln, who will be presenting today for the working with CAD in GIS. Okay, over to you, Lincoln.
Thank you, Manish. Give me a while I set this up. So hi everyone, and welcome to this webinar on working with CAD in GIS. A little bit about myself before I start off this webinar proper. So I graduated from National University of Singapore with a degree in electrical engineering, where my area of specialization was in satellite systems design. I also obtained a minor in GIS from NUS. So the main reason I gravitated towards the GIS industry was the sheer number of applications that it has to offer for both governmental bodies as well as students doing research. And also the fact that satellite imagery was being used for analysis by the end users. Now let's have a look at what we will be covering for this webinar. So I'll start off with explanations of CAD and GIS format, so that the foundation can be laid for those who might not be familiar with these data types. Then we will be following by, this will be followed by showing a few capabilities of the interoperability between CAD and GIS, which will be highlighted in the case studies that I will cover. The final section of this webinar will be to showcase the CAD to GIS conversion process through demos. At any point of time, if you have any burning questions, please do note it down and ask at the end of this webinar so as to not distract anyone. So let's start off with CAD. CAD is basically an acronym for computer-aided design. It is a software used by design engineering professionals to create and document real-world objects. So currently, AutoCAD and MicroStation are the two most widely used general purpose CAD platforms. These systems are designed to accommodate a wide range of applications. So organizations involved are in engineering, architecture, surveying, and construction industries. They use them to provide a variety of services. Now moving on to So I'll show you a brief introduction to the capabilities that Esri software have with this short video. So just sit back and enjoy this.
digital transformation is taking place, and the world changes in the blink of an eye. Esri users are unlocking the full potential of data to solve real problems in real time. They use location and geography to integrate, analyze, and understand all types of data. They embrace the science of GIS, science that Esri pioneered, and its users continue to advance. Organizations everywhere see data in new ways through a common visual language. Informed, inspired, and empowered by the science of where, pushing the boundaries of geography to create deeper insight and understanding. The science of where is the science of exploration and navigation, the science of the grand and the granular. This is the science of development and the science of sustainability, the science of power and the science of peace, the science of will, the science of wonder, the science of where.
So now moving on to the GIS aspect of things. A GIS file format is basically a standard of encoding geographical information into a file. And most of the time we see this either in like vector or raster format. Here are a few examples of what different formats are available in the GIS platform. GIS also has a versatile applications. GIS applications are mainly tools that allow users to create interactive queries. We also enable the analysis of spatial information, editing data in maps, and also presenting the results of all these operations. Now, GIS has proven itself as an organization-wide enterprise and enduring technology that continues to change how local organizations operate. A very good example would be government agencies that have adopted GIS technology as a method to better manage the various areas of government organization, from demographics and urban development to disaster mitigation. The interoperability between GIS and CAD is actually very, very useful. What you have here is two separate entities like engineering, procurement, or the projects team. And on the other side of organization, you have the finance, sales, and operations team. So if CAD data is needed, it usually is kept within the engineering and project team, with the other departments having little to no knowledge on how to read it. So what the interoperability between the two platforms creates is a more seamless workflow in which all information is available to all departments at all times. Now, there are two aspects to this interoperability, and we have ArcGIS Desktop on one side, which is capable of reading CAD files of different formats. This is the platform I'll be using for the demo later on. And we also have ArcGIS for AutoCAD, which is a plugin which is available for free. With the plugin, what we have is an access to GIS maps and imagery. You can integrate your existing GIS data to the CAD files. The data can then be edited, and this CAD can be converted to GIS data as well. And when it comes to location, you can use street addresses for navigation and analysis, network analysis. And lastly, but most importantly, all this information can be shared between groups or departments within a particular organization. So apart from the plugin, let's get to the ArcGIS Desktop. So what the desktop does is it accepts data generated by AutoCAD and MicroStation-based applications. You can assign coordinate systems to the features and place them on an accurate location on a map. You can symbolize to fit your visual representation required. 2D data can then be turned to 3D data not just above ground, but underground as well. And finally, you can always export the final data back to a CAD format if it's needed. Now let's move on to a case study in which this conversion was used extensively. Black & Veatch is a global leader in engineering, procurement, and construction services for energy, water, and telecommunications. So for Black & Veatch, the incorporation of ArcGIS for AutoCAD is speeding the workflow from the field to the office to engineering and then production. When field crews go out to survey the road for fiber installation, they note poles and other assets along with field conditions. So they're basically taking any incident reports. And office workers can view data, add to it, and perform quality control. The engineering team then can reuse all the field collected data right away. The CAD workforce can access the same data on demand. So what we have here is previously the data would not have been so easily accessible, locked up in a file or a spreadsheet somewhere, with various departments working separately from one another. But with the conversion and the integration of CAD and GIS, what we have is a seamless platform in which all the different departments can work together without having any abrupt transition periods. So that was an example, like more of an international example. Now let's move on to a bit more local example. So in Singapore's context, we have an enterprise client who had CAD files of pipeline networks for over 30 years. And they needed to break away from this traditional workflow in which every time a new pipeline needed to be constructed or extended, they had to create a brand new CAD file, and the engineering team would just keep on repeating this. So over time, this led to a situation in which there are multiple CAD files for the same location that is not integrated. And on the other end of the spectrum, you have the key accounts management, who had to refer to Excel sheets in order to refer to the financial information of these pipes for like lease, rate, and capex values for the construction. On another end of the spectrum, you have a service operations team who had to manually take down the inspection findings, come back to office, rewrite all the findings into a specified format, and then raise a notification to SAP. So our solution that we created for this particular client, with the inclusion of CAD conversion in GIS, these departments can now work in tandem with each other, as all the data is provided on a single platform, regardless of whether a web application or a mobile application is used to view or analyze this same data. One of the uses of this conversion was that the operations team was able to take down inspection findings directly on the platform with the use of a mobile application like Collector. So you can see here we have the utility network, the inspection reports, which are basically tagged to three different types, which is either maintenance, normal reporting, or violation. And at the moment they enter this inspection finding, it is directly linked to the platform, and the colleagues who are sitting in the office are able to access it through a web application. We also have a better way of visualizing the data that was converted from CAD, as it was projected in 3D. So this is what it looks like. This helps the engineering team to know exactly how many pipes are on a particular platform and whether there's space available for any future pipes to be constructed. So that was it for the case study for our local client. Now let's get to the fun part. So I'm going to try to do something here. I will try to time myself for the conversion process, which will be the manual one. And then we'll try to see if the automated version is going to be any faster or not. But even though a few of these intermediate steps might actually be pre-prepared. Okay, so what I have here is a sample CAD file from San Diego. I'm just going to open this in a DWG viewer first so that you can see what it looks like from a CAD perspective. So, I mean, this doesn't make any sense right now because there's no annotation. But if you were to open up the layer properties, we can see that there are a lot of different features that are tagged to this particular CAD file. What we need to do is isolate the feature that we want to convert, because obviously not all the information will need to be converted in the GIS platform. So for my interest, I'll be looking at buildings. You can see which one it is if I just on and off a layer. So I'm going to open this exact same file in ArcMap and see what we can do with it. All right, so let's drag that in. You can see in the catalog tree, it already has all the different layers that are attached to the DWG dataset. For our interest, we are only concerned with the polyline feature here. So we are going to unselect the rest of them. Okay, so we're left with only the polyline layer. Next up, we are going to export this data into a feature class. So we have, I'll just call it export. Okay. Yes. So at this point, let me switch off the CAD polyline part and let's look at the exported one. Let me just open the attribute table so you can see what are the different attributes that were carried over upon the export. So we have entities here, we have layer. So this layer is basically the one I was talking about. Building is what we are concerned with. There'll be a lot of other, there's drain, fire system, laser lights, so on and so forth. So I'm only concerned with building. So I need to do a further filtering of the data now. So I right click on the export and then I go to properties. I do a definition query on the layer. And let's scroll to the building part. There we go. Sorry, my bad. Okay, second time's the jump. Okay, so based on the definition query, you can see that this is the only features that fall under the building category. So what I'm going to do next is extract this data, export it again. This time we'll call it building. So what we have finally is only the building layers. So we have sieved through all the irrelevant layers and we're finally left with the building layer. Now we need to create a schema in which all these features will be ported over to. So to save some time, I've already created a schema here, because we might not be interested with all the different fields that are available. So in this case, I'm only concerned with layer. Yeah. Let's move on to schema. So in schema, we have layer, building type, as well as shape length. So what we're going to do now is append it to the schema. So this is one of the geoprocessing tools that you'll be very frequently using if you were to do any CAD to GIS conversion. So my input data set will be the building, and then target is the schema. So you can see that the geoprocessing tool is working as it's loading over here. And I guess that's completed. Okay, there we have it. So it has been appended to schema. I've added this new field called building type. This is for me to merge with other data formats that might be available, like for example, Excel sheets. So I can join that Excel sheet with this table and then have all the relevant building type subtypes. So basically that's about it for conversion from CAD to GIS. Of course, if you want to do some post-processing in order to project your 2D data to 3D, you can always do so. Okay, that roughly took me about, I would say, more than 10 minutes. So let's have a look at the automated version. So for the automated version, so what we went through here was actually, we exported the data, and we extracted the features needed, created a schema, went on to select the features, and then if any post-processing is done, we will actually use a tool to create that. So now looking at the automated version of the workflow. So this is the similar CAD file that was provided by our clients. There's a lot of irrelevant information here, like for example, the cross sections, the annotations, which will not be required for the conversion process. So what I'm going to attempt to do is open a DIE tool that will allow for automated conversion directly from CAD to the feature classes with all the relevant attributes intact. Just give me a while I open up the data interoperability tool. Okay, this is what the automation process will look like. Just put that to full screen. So the input here is going to be a CAD format. Let me just zoom that in. So you can either select it to choose only a specific CAD file, or you can batch process them by selecting multiple CAD files. And then we go through some initial filters, testers, and some geometric manipulation. Then there comes the merging of data with the other CAD files, as well as Excel sheets. And then we have the output here. So I can visually see the changes that are happening along the way here. So let me just run that. So we'll be able to see the CAD input as well as the output that we get. This is just doing a CAD to 2D feature layer conversion. So it's still all going to be flat. Just give it some time. It seems to be a lot of different features. Okay, so this was quite a lot of features, and it took only about 28 seconds. So let's have a look at the view. So this is a data inspector that is inbuilt into the DIE tool. I'm sure most of you can recall, we just had a look at this in CAD file. So it retains pretty much all the different features that are available in CAD, from annotations to points, polylines. But what we are concerned with is to extract a simple portion of this line, which is between this crosshair to this crosshair, and save it as a separate entity in a particular layer. So that's what my automation tool is actually trying to do here. And if I remove the CAD input, this is what I'm left with. All the different lines that are throughout the entire CAD. Now moving on to the post-processing part. So if I was to try and project this into 3D, so I created another tool separately for that, just to avoid any user input errors. So this is the projection tool. And all it does, it takes those lines, creates duplicates of them, and then tries to project them into 3D with different elevation values. Let's try running that. Okay, that was pretty fast as well. But here the thing is that our data is going to be in 3D. So this is the 2D input layer, and this will be my 3D output. So you can see all those lines have been duplicated and projected into different elevation levels. Okay, so that brings us to the end of the demo. You can see that inclusive of the post-processing 2D to 3D conversion, it only took me less than a minute probably to run that file to obtain it in a GIS format. So let's get back to So when it comes to this conversion process, like I said before, there's a lot of unwanted information in this CAD file. And most of the clients we have usually received the CAD files from, they tend to cluster a lot of information into a single CAD file. So before processing or conversion even takes place, it is pretty important for those who are doing the conversion to sieve out the relevant information first. So there are two ways to doing the sieving. You can either import the entire CAD file into your ArcMap and then extract the relevant information, or you can even separate it within AutoCAD itself. So I can cut out sections of this CAD file itself and then do the processing without having to deal with the unwanted data. So in this case, I can just probably chop off at this line itself, because all those information on the right-hand side is irrelevant for the conversion to me. One, just thought of this. This is one limitation to the automation process though. While it can pretty much do all the extraction, merger of different format of data, as well as projection into 3D, it is still incapable of doing georeferencing, which still has to be a manual process. I'm not saying that it's not possible, but it'll be a bit tedious and only possible if the CAD drawing comes with coordinates assigned to it. So that was the end of the demo. Moving on. Okay, actually, before moving on to the next portion, I just want to show you what, after georeferencing, what does the information stored looks like. What I have here is the georeferenced CAD file, which is this one. So after the file has been georeferenced, it will come up with the WLD extension. This is basically attaching coordinates to two control points. And you can view that coordinate inside a notepad. There you go. So there are two control points here. So overall, what I covered for the manual here is the workflow that is highly manual, as well as the workflow that is highly automated. Both have their advantages. If you're facing a lot of data that is sporadic in nature and you do not have any standardization, then it is more advisable to use the manual workflow, because you won't be able to use the same workflow for all the CAD files provided in a batch. However, if the data is from a single provider and there's a lot of standardization between the features and the annotations that are used, then it's advisable to do automated workflow, as it will save the organization a lot of time. Now, to sum things up, what the conversion process does is that it greatly increases our efficiency in the organization, because it has the capability to greatly reduce and break the abrupt workflows between different departments. So what you get is a seamless integration between seamless integration of workflow between different departments. What it does is it increases efficiency, and it reduces the overall time taken between the ideation, planning, and procurement for organizations. This conversion process is also intuitive and highly replicable. The reason I say it is because I'm using a graphical user interface pretty much the whole way through. And the procedures are 90% the same regardless of what CAD file you use. There'll be slight tweaks here and there based on how the contractor draws the CAD file. But other than that, most of it is going to be pretty much standard. And coding is also not required for the conversion workflows, so for people who do not have a background in programming language, they can still automate these workflows without writing a single line of code. And for those who actually are more prolific in writing code, they can still use Python scripts to run bad jobs. So it's not a one solution fits all, but whatever platform you're comfortable with, you'll be able to use it for the automation as well as the conversion. Also, because of the no coding required part, the learning curve is pretty gentle, and there won't be any steep learning curves when it comes to transferring knowledge between two people who are working on the same conversion process. So with that, I come to the end of this webinar. If you're interested in learning about how to do CAD to GIS conversion with instructors guiding you along the way, I strongly recommend that you sign up for Working with CAD in ArcGIS training. It's a short one-day course, and it will expose you to a lot of scenarios that can be used for the conversion workflows, with more tips and tricks to make the conversion process a lot smoother. So now I'll leave the floor to you guys. So if you have any questions, please do raise them now. Okay, it seems we have a question from Ahmad Ali. Thank you, Ahmad, for the question. Ahmad says, what could be the possible uses of GIS in the file of agriculture? I think you mean field of agriculture, right?
Field.
Correct me if I'm wrong. Okay. So the possible uses of GIS, what I can think of that from the top of my head would be, you can still perform statistical analysis. You can capture crop data and maybe do some change in vegetation analysis. What else? Let's see. Maybe you can induce the data with weather feeds to understand the behavior. And you can also use temporal data as well for your studies. And I'm pretty sure there might be more applications, but off the top of my head, this is all I can think of. Do we have, I hope that answers your question, Ahmad. Or would you like me to elaborate a bit more?
We have a few more questions coming in.
So somebody who does not want to name themselves has asked me a question. So we have an anonymous question. Does the tools limit to ArcGIS version? Okay, maybe I'll try to separate this question in a way that, so when you're talking about tools, I assume you're talking about geoprocessing tools.
Yeah.
And DIE tools as well. So while it is version limited, most of the tools that I use right now have been available since ArcGIS 10.2. So if you're running anything from ArcGIS 10.2 onwards, you should be able to use all these tools. Okay, we have a few more questions.
So we have a
from
question
Louis. Wait, hi. So Louis asks, we are wondering how you import the cross section from CAD and display in 3D. Okay, Louis, I mean, while the cross sections can actually be imported into ArcMap, we can't project them into 3D right away. But what we can have is to use the 2D data that is already available, use this elevation, and then have like a plane passing through, like a cross section through all these entities. I mean, the main purpose of cross section in the first place, I mean, is to view 2D data and make sense of it in 3D. So if you already have data that is available in 3D, the cross section doesn't really serve any purpose. I hope that answers it. We have another question from Ahmad Ali. Okay, so Ahmad asks, like, we can check out the soil types, sandy or clay type. Okay, I'm not sure if I understand this question, but I'm assuming that you are asking if attribute values will be kept along with the feature types, and the answer is yes. You can tell if you can have a field that identifies the type of the soil, and you can also do analysis on it based on like count of sandy type, clay type, and you can, and as long as the attribute types contain soil types, you can use it to visualize boreholes in 3D. Okay, moving on to the next question. Mr. Chandra, hold on for a while, Luis. I'll get back to your question in a while. Mr. Chandra asks, is it possible to me to download template for the exercise? I'm sorry, we do not have any templates for you to try out the exercise for free. But if you're interested in just checking out how the interoperability works, you can try to download the plugin, the ArcGIS plugin for AutoCAD. It's free, and you can probably play around with that to see if it meets your need. And next up, we have another question from okay, so Louis, let me get back to your question. So your question was, we're wondering if you import cross-section from CAD and display in 3D. Okay, if your question is, okay, how to import the cross-section, I think I can pass this over to Manish because he's more tapped.
Hi, Louis. This is Manish. Thanks for joining this webinar. And to answer your question, that we are wondering how you import the cross-section from CAD and display it in 3D. Well, there are two different ways. One would be wherein if you want to, like if you convert your existing CAD data from 2D to 3D, and you can have a link passed in as a URL, which can open up the cross-section file of the CAD that it contains it. That is one way to do. Other way to do is wherein you can actually have a elevation profile generated from that particular 3D data that is converted from CAD. But for the elevation profile, you might have to, there will be required some more additional work other than just simple conversion, because there will be certain tools and certain plugins and add-ins which will be required to do that. I hope that answers your query.
Actually, while everyone is still asking questions and I'm attempting to answer them, could you all please help me to complete the survey, as it will help us to improve our webinar content for subsequent ones. So please take your time, and I'll still be answering some of the questions here. Okay, we have another question from Louis. Okay, so the question goes, we actually want to understand in the event, we have the cross-section for each floor of the building, but without any coordinate on it. How are we going to synchronize with other layer that you imported, such as road and etc.? Okay, so Louis, this is where the georeferencing actually comes in. If you do not have any coordinates assigned to your CAD file, the georeferencing will help to adjust it to a particular map. And since the map is already georeferenced, all the different coordinates, like for a building, let's say we have a simple rectangular top view building, we can assign all the four corners to coordinates. And once the X, Y coordinates are set, the Z elevation can be set thereafter. So the georeferencing will basically synchronize with other layers. I hope that answers your question. So we have another question from Benny. He's asking, why is CAD still being used so extensively if GIS formats are so versatile? Well, this pretty much depends on the organization you work for. Well, CAD has a lot of accuracy and attention to detail for engineering workflows, but when it comes to organization that has key accounts management, your engineering team, as well as operations, in order to make sure that all these different departments are able to view all their data on a particular platform, GIS still fits the need. And what CAD cannot do right now is do data analysis, because there is very limited data that can be added to CAD, and analysis still can't be done. So GIS helps to bridge that gap. And CAD has been around for a long time. So a lot of the drawings that are done, like civil drawings, are usually in 2D. And now everyone is trying to shift to a 3D format. So geometric manipulation also needs to be done. And that's where GIS comes in. I hope that answers your question, Benny. Thank you for the question, though. Okay, everyone. I hope you are done with the feedback. That's all the time we have for this webinar. And for any further questions, I will try to email them the answers to you. And yep, thank you. If you want to stay connected, you can always reach me at my email address. And any technical support can be addressed to support@esri.com. You can connect to our sales and commercial as well at connect@esrisingapore.com.sg. So that's all the time we have for today. Thank you everyone for joining in. And I know it was a short discussion about the conversion, and it was a lot of information to sit through in one sitting. So thank you for your patience, and I guess we'll see you in the next webinar. Thank you.